Okay, let's get started. So hope you had a good weekend. Thanksgiving is coming up. So it's obvious you want to talk about the midterm right now. So sample solutions are here. So bubble sort on this list for one iteration, meaning one pass through the list. So let's see why this is the answer. So our original data was 7, I'll just put spaces, this data. So on the first pass, what do? Yeah, do we switch these two elements? Yeah, why? They're in the wrong order, so we swap them. So that we're not done with one iteration yet. What about these two? Are they in the wrong order? Yeah. So swap them. Are these in the wrong order? No. Do I continue? Yes, good. Do I swap these two? Yep. Do I swap these last two? Do I continue more on this one iteration? No. So 5, 3, 7, 2, 6, 9 is C, and that's why that's the answer. For selection, so here, what order will the data be in after the first pass? Pass in this sense means I scan for the minimum. So I'm going to look up, first off, what is selection sort going to do? So it looks at this first element 7, and then what does it do? Yeah, it swaps 7 with the minimum. Well, where's the minimum? What is the minimum of this list? 2. Okay, so it swaps the 2 and the 7. So if we copy this down, swap the 2 and the 7, and then that's why A is the answer here. Okay? And we'll come back to this for the second question, the short answer question. If one algorithm takes 2n plus 1 basic ops, and M2 takes 3n plus 2, then what are they? Equivalent or what? Yeah, they're equivalent. Why? What did our notion of equivalence say? If the runtimes, if you had one divided by the other, they approached some number. So they have the same growth rate. So do 2n and 3n have the same growth rate? Overall growth rate? Yeah. What if I put instead n squared there instead of 3n? I put 3n squared. Yeah, they're different because one is growing like n linear, so it's going like a line, and then n squared is going up like a curve. So the relative difference between them is growing. Whereas for 2n and 3n, the relative difference is the same. The absolute difference is growing, but the relative difference is the same. Or it's approaching 2/3. That's the key there. Most people got this one. So I haven't graded this. This is not done. I have a lot of things that are due today, but I'll try to get them on Wednesday. If not, definitely next Monday. But I'll try to get them on Wednesday. But the ones I've seen so far got most of this right. So this one is equivalent to what? A, right, because we're doing the pointer arithmetic first, then doing the dereference. So, and these ones are just basic variations that don't work or give you the wrong answer. So this one, I'm still debating. I still believe that E is the right answer, but I think A could also be the right answer because this is not a sentence. But if I put the word points to right here at the beginning, that is correct because a dangling pointer points to a block of deleted memory. So the pointer is still there. It says, I'm pointing to this address, but there's nothing at that address anymore. So A could be the right answer. I'll still have to see how everyone did on it. But so E is the right answer from here, but I can see how A could also be the right answer. The other three are definitely not correct. Any questions on number 5? Okay. Number 6, what is the purpose of a smart pointer? Does it automatically free memory when leaving current scope? Yep. Does it avoid dangling pointers? Yep. So this one, do I need to look at C? No, because it has to be D at this point. It can't be A and B and not be any of the other ones. So it has to be D here. And it does manage objects through pointers easier because you don't have to call new and delete yourself. Which operators should be overloaded to have array-like behavior? Yeah, square brackets, because we want it to look like an array. So this is how vector implements the square bracket operator. It overloads that, and so we can have array-like behavior, even though it's doing something else. Okay, what is an R value? It's actually D, because it's some memory, but we don't have a name assigned to it. If it has a name assigned to it, what is it? Is it an R value or what else? L value. So L values are defined to be something that you can take an address of, but something that has a name, you can take the address of. So if it doesn't have a name, we can't take the address of it, and so therefore it is an R value. Why do we overload operators? Is to operate on more operands than we could before, because we could operate with the dot operator pretty much only for classes that we define, but we can overload plus, function call, square bracket, overload assignment operator. All those operators we can overload to do something else. So we can operate on more than what we were allowed to do before. So that's the main reason why we do it, just to make it easier to implement basic op. Mm-hmm. It doesn't tell you, well, if I have like an object of type A and another object of type A, and I put plus, the literal plus in between, that's not actually defined to be anything unless I overload the operator. Well, it's true, but the thing is that this is not the justification for this. It can be used for it, but that's not the reason why we do it. Yeah, so it's basically so we can use operators on user-defined types, but it's not the. But just because it can do this, this is not the justification for why we do it. What about the last one? Why do we use default with respect to construct? Yeah.
Back to number 9. I remember I was back and forth between B and C. I ended up like erasing one and putting the other like multiple times just to like reiterate.
Oh, okay. I can see how B could be the right answer. Yeah, I think you convinced me. So 9 can be B or C. Yeah, I can see how the ambiguity can be here. Yeah, B or C is fine. So I'll have to go through the ones I already graded. But for number 10, why do we use default with respect to constructors? Let's see. So does it avoid the need to write constructor implementations? Yeah, that's true. When the class changes, does the constructor change? Yeah, it technically changes because now if we put default for the constructor, then it must do something else if we change the class. We don't have to type that, but the constructor does do something else. So A and B are definitely right, so it's either D or E at this point. Does it make move constructors faster? No, it doesn't change how the implementation is defined. It's just that we don't have to type it ourselves. So E is the right answer here. Yeah. With respect to. Yeah. Some people asked about that. I probably should have. The only reason why I shorthanded it like this is that I can fit it on one page. That's the only reason, but I can see how someone could get confused if they've never seen that before. But you should have seen constructors there, and so default and constructor, something to do with that. Any questions on the multiple choice? Okay. So From what I've seen on the next 3 questions, you really need to look at the all of the things that we've covered, especially in the big O / performance, all that stuff. So some people put like a specific list, like 1, 2, 3, 4, and said, yeah, that's a list that produces an optimal best case performance for bubble sort. Does that work in true necessarily for this one list of 4 elements? Does one example prove a statement? No, so you have to show that it works for all n, which is why I have here, for any list of n numbers, here's an example. So this works for any length of list that you want. I can't just say 4, 3, 2, 1 and say, yeah, that'll give us the worst performance in general. So remember, big O notation is about how does the algorithm work in terms of n, which is the length of the list. So bubble sort, for worst case, here, each element has to go roughly, on average, half of the list. So each of the elements has to move about half of the list on average, but each element can only move one element at a time, or one place at a time. And so you have order n, big O of n, number of things to move, number of places to go, and that means that the number of passes must be order n also. But each pass along through the array, I have to read the entire thing just in case I may have to do a swap at some later point. I need to do order n squared operations for this list because there are order n passes through the thing, and each pass takes linear in the list. Yeah. Yeah. So you're technically right for that, but here we're ignoring like n minus whatever. This is just the performance as n grows larger. So think about the basic operations from this example earlier. So 2n and 3n are essentially the same. They're equivalent to each other. So any number times n, that is the same. But if this is like n or n minus 1, that doesn't actually matter. And I'm not going to take points off of that because we haven't really covered the formal specification for what big O means. But I need to see something like, yeah, I'm going order n or n over 2 or whatever number of places. So I'm going to be lenient on this question, but some people went really astray in terms of trying to explain how long the algorithm actually takes on this list. But the one that does the best for bubble sort is the one that's sorted because, well, think about it this way. How can I get bubble sort to exit or stop executing as fast as possible? Well, think about how the bubble sort algorithm actually works. And I'll actually go to the code example that I have here. So here's the bubble sort implementation that we have. Ignore the fact that it's arrays. Just think about this. So the only place I'm returning is at the end of this function. So down here is the only way I can exit the function. Well, it says, while this swap variable is true, I'm going to keep going. Okay? So what is the fastest way that I can exit this function? We'll get to that. So if swap never is set to true, what happens? It just starts as false and is never set to true. What happens? Don't I exit the loop immediately? Yeah. So if I never set swap to true, then we're in good shape. Well, how do I set swap to true? Well, the only place I see swap setting to true is right here. Well, how do you get to this point right here inside of this if statement? Well, this if statement better be true. Well, when is the if statement true? If it's not sorted. When one element that's further along in the array is less than the one that comes before it. It is in the wrong order. So if I give you a list where none of the adjacent elements are in the wrong order, then this swap variable is never set to true because I never do a swap. And so therefore I exit as fast as possible. So you don't have to provide this list. You can just say any list in sorted order. That's fine too. Because we only make one pass through the entire array, and the pass takes linear in the length of the list, and there are n elements in the list. That's why it takes order n steps for this list. Yeah. So what about selection sort? So this goes back to this point right here. Okay, so it turns out no matter what you do, selection sort will take n squared time, no matter what. So why is that? So let's go back to selection sort code. Let's see. So how many times am I going to do the outer loop right here? How many does it look like am I going to do? Well, I start at 0, and I add 1 to this start scan variable every time, and I go to size minus 1 on the order of how many iterations am I going to do of just the outer loop. Size, right, because that's how many times I'm saying the loop is iterating. Well, note, inside the loop, is there like a break or a return statement anywhere? No. So in fact, I'm definitely going to go through all that number of iterations. So let's just call size n for our purposes. So that means that no matter what, I'm going to execute this outer loop order n times. N times, actually n minus 1 times, but order n in general. Well, what about this inner loop? How many iterations am I going to do of the inner loop? Well, it says I'm going to start at start scan plus 1, go up to size, which is as far as I can need to go. Well, let's see. So the number of iterations of the inner loop is going to depend on where I started from, where start scan actually is. Start scan starts at 0, but if start scan is further along, then this inner loop is going to execute fewer times. So the answer may depend. But think of it this way. On average, where is index going to start at? Well, at the beginning, it's going to start near the beginning. But if start scan is way near the end, is index going to also start near the end? It's not a rhetorical question. Yeah. Well, on average, where is index going to start? This variable right here is going to start at the beginning, the end, or somewhere in the middle. Somewhere in the middle, right? So on average, I'm going to do about half of the number of elements in the list for index. So let's see. Order n iterations of the outer loop and about half of the number of elements of the inner loop. So n times, you can either think n or n over 2, doesn't really matter, is n squared. So in fact, no matter what list I give to this, it does not matter. I'm going to still do n squared operations, yeah. But the question here is, yeah. For a list of size 1, so let's see. Well, I got to make sure I'm setting size to be 1, just to be, if I feed size to be 10 and there's only one element, that's kind of cheating, right? So let's just say size is 1 here. Size minus 1 is 0, right? And so this outer loop will not execute. And if you think about it, a one-element list, is a one-element list sorted? Yeah, vacuously. So in fact, yeah. But this question is about if I provide you an n-element list where the list can be as long as you want, what is the relative performance of that algorithm? And in fact, for best and worst case for selection sort, it does not matter because the algorithm does not depend on the list. Right? It makes a swap at some point, so that may affect the number of iterations that I'm doing, the precise number, but here, in terms of big O, it does not matter. It's still n squared no matter what you do. Okay? And for the bonus one, if you just randomly sort the list, just sort the list in any order you want, random order, how long should I expect them to run for? Well, selection sort for this reason, what should it take for selection sort? Well, selection sort takes how long for every list? N squared. So what should I expect it for a random list? N squared also. It's the same for every list. But for bubble sort, the expected place of every element is, well, it could be at the beginning, it could be somewhere in the middle, or it could be at the end. It depends. But on average, it's going to be in the middle for each of the elements. But for each element, I'm going to have to do roughly a quarter of the list to move that one element, because if it's near the beginning and I'm expecting it to be in the middle, on average, I'm going to have to move it to the first quarter placement in the list. And if it's near the end, I need to do it to the 3/4 position. So on average, I'm going to do n over 4 placements or passes for each element. And each one takes order n time. So it's n squared for bubble sort also. Any questions for question 2? Yeah, so this one I'll be a little bit lenient on this one. Question 3, this one was quite well done for the people I've seen so far. So the answer for each one can go either way, whether to use a pointer or not to use a pointer. You have to justify why you're arguing in that position. But there's no completely right or completely wrong answer. It just depends on your justification. I mean, if you don't provide a justification, it's completely wrong. But if you provide a justification and it's valid, then I'll give full points for it. So if you have a database of all ASU students hosted by ASU servers, then you could say, well, you could have a unique pointer here. Actually, you should say that I should have a pointer because there are so many students, and if I need to allocate more, then I don't want to put that all onto the stack. I want to put it all into the heap to dynamically allocate it. So a pointer is a good place for that, but you could also argue that each year or each semester, I only need to do the allocation once, because after the deadline of applying to ASU, you're not going to get any more students necessarily, although that's not really true, but you could assume that there. And so you only need to do the allocation once, and so you could put that onto the stack. It's not necessarily a bad thing in that case. So I would say that my opinion is that the database is large, so a pointer is better. And if you say pointer, should you ever say raw pointer? Is a raw pointer ever better than a smart pointer? No. So in fact, you should always use smart pointer here. The database is pointed to by many servers. Because I said servers, I should say that a shared pointer would be better, because you don't want to reallocate this list many times, and so you just want to share the pointer among all of the servers. But you could say the servers are one entity, and so you only need one pointer out, in which case you have a unique pointer. So all 3 ways of arguing are correct depending on the justification. Pretty much everyone got this one right, fully right. The document creation service uses shared pointer for that. I don't really see how a unique pointer could work there. This one, a container like vector that holds an arbitrarily large number of integers. The distinct here doesn't matter. I just have arbitrarily large number of integers. So that should tell you I'm going to allocate this on the heap. So do some dynamic memory allocation. So if you have a container like vector, then the object itself is responsible for the data, not like a whole bunch of these containers together are responsible for the data. So in my opinion, a unique pointer is best here. But you could argue potentially that a shared pointer could work, but you have to argue that that would be a sensible thing to do. A menu at a restaurant doesn't change items or prices. In my opinion, I was going for you to think, yeah, you don't need pointers for this because it doesn't change. But some people pointed out you can use a constant pointer to a constant value. That is a good way of approaching it also, because maybe you don't want to have that memory allocated on the stack. You want it in a pointer where it's easily managed. So a pointer could work here. I was going for, you don't need a pointer for this, and I still think you don't need one. Yeah. But I said that if you had a non-pointer data structure, you should actually mention that. What I would think would be best for what we know is a vector here. So if you don't want a pointer yourself, just use a vector. There is something called a set. I'm not sure if we talked about it, but it's going back to the, a restaurant menu doesn't have duplicate items, so I think a set which doesn't have duplicate items is best here. Okay, any questions on question 3? Okay, question 4. So this one, I would really strongly urge you to look at the solutions for this question. Question 3 was very well done. Question 4, not so much. So for question 4, for the copy constructor, this, if you look at it, is copying the other object by value because I don't put a reference here. And if I'm copying from the other object to ourselves, do I want to modify the other object necessarily? No, I don't want to modify it because it's copying the data over from there to here. So that's where you have to say, make it const and pass by reference. So it should say const a ampersand other, const a ref other. So I noticed this had a bug in it, so I just uploaded these. There's a slight change down here. For the assignment operator, because I'm assigning from one thing to the other, I don't want to have to modify the original because it's just the copy assignment operator because I only put one ampersand here. So you want to make this const. So that was what I was going for on that question. But I put void here. You don't have to put void here, but the convention is to put a ampersand right there because the convention is that you return an object of that type when you do the assignment operator. But you didn't have to do that, and that's a full credit answer also. And some people did put that, which is also correct. Another fully correct answer for all of these is, what is a class's visibility by default? Is it private or public? Private. So what do you think the copy constructor, assignment operator are all doing? Private. What are they by convention? Public. So if you put, this one should be public, this one should be public, this one should be public, that's full credit too. Because I screwed up and tried to fit it all on one page again. All of these should have the public specifier on them. Okay, so for C, I have the move constructor here, and how do you know it's the move constructor? It has the double ampersand there. And so what is the issue here? Well, if I'm moving the data from the other object to ourselves, should I keep other the same thing? Or should I modify the other object? If I'm moving it from here to here, I'm not copying. So am I modifying the other object? Yeah, I'm in fact modifying the other object. But I put const here, meaning I'm not changing it. So the convention is remove the const from here, because we are modifying the other object. So for part D, I say let's sort a vector in ascending order. But what's the error? This should be x less than y. X. I think I got this wrong. I say x less than y here, but I think that is correct. Yeah, so part D actually is correct. Oops. So making tests is hard. Yeah. Well, that would always return true, but I see what you mean here. Yeah, but it's just, is it ascending order in that case? Well, let's see. What is the number one way that I could see the error of my ways in my C++ code? Well, let's just test it. So let's, so let's do this. I'm not sure why it did that. So let's just do a test. Let's just put it in wrong order. And then let's, for each element in vec, let's see out lm with a new line. Oh, I need a semicolon at the end. Okay, so yeah. So anyone who put anything for part D is full credit. Yeah. My mistake. I meant for this to be in the wrong order, but my bad. And this one is also another my bad. So what I wanted this to do is pass in the m right here. So m is being passed into here, and we return here, but I'm passing by R value reference. So does R value references, as we understand them, modify the object? So if I'm moving from one thing to the other, does it modify the original? Yeah, we just covered that. So what I wanted this to look like is I'm passing m into this function right here. It's modifying the original m because it's doing a move over to here to the function object, to the function. And then when I try to print here, it's trying to print something that was modified. And so that's something we potentially wouldn't want. And so as we understand them, the right thing to do is to remove one of the ampersands to make it pass by reference so I don't modify the original here. Well, I don't modify the original in a way that I don't want it to be modified. Because I may do stuff in here to the string inside of the function, but that's okay because I'm passing it by reference anyway, so I expect the original to be modified by whatever the function actually does. But as we understand them, R value references are not the right way to go. But it turns out that this code is actually correct, other than S being the wrong parameter here. For technical reasons, which are stated down here, I'm not going to cover them. But if you're curious as to why this code is actually right, you can look down there. But so what you needed to say here is that the R value reference modifies the original in a way we don't want it to be modified. Or the other answer is that you're passing S into here, whereas you should have passed M, you doofus. Okay, so any questions about the entire test? So hopefully I'll get to these back to you on Wednesday. See if I can stay awake that long. Any questions about the test, though? Yeah. Yeah. Yeah, good thing you asked that. So for the final exam, what I want is that it should be a comprehensive testing of everything. And I don't really want any one thing to be tested more than any other thing. I want it to be a uniform distribution over everything that we've taught. So not like more emphasized at the end. I want everything to be tested equally to show that you really understand the beginning stuff and the end stuff. So how many sets of slides are there? 12. And how many questions are on the final, if you remember? 75. So I'm expecting between 6 and 7 multiple choice questions on each of them. Now, some of the sets of slides are longer than others, so maybe you should expect more on those ones and less on the shorter ones, but I'm trying to keep it equally as much as possible, okay? And I'm trying to go for not having any gotcha questions, but more of, do you actually understand how this works? Do you understand what a passing by reference versus passing by value is? Do you understand L values and R values? Do you understand aggregation and composition? Do you understand the types of for loops we looked at? Do you understand the difference between an array and a vector, for example? So those types of questions that are testing your concept, testing the concept of whether you actually understand the general idea more versus the details, because on the tests, I've already tested you on how to program. So I'm assuming you know how to program by now. I'm testing you on whether or not you can actually think critically about whether you should use this concept or this one. So a question that I like on tests is, suppose I want to solve this problem, and here are some specifics about the problem I want to solve. Should I use this concept or this one? Should I use a unique pointer or a smart pointer here? Should I use a for loop or a while loop here? What is the more sensible approach? I think those are good questions because it makes you think about what is the best way to approach solving problems, because this class is about problem solving using programming. Okay? Any questions otherwise? Yeah.
So you said it's going to be multiple choice though, right?
Mm-hmm.
So like the only issue there is that like obviously with coding, everyone has a different way they're going to approach the problem, so people can have different reasons that they would do different things. So like how are you going to factor that into the fact that it's a multiple choice test? You're asking what's the best way to do that? Because that can be somewhat opinionated with coding.
So like, yeah, I see what you mean. So like, for example, one of the questions could be, that this will not be one of the questions, but here's one. What's the difference between a for and a while loop, for example? Like in terms of like what you can actually do with it. There's obvious differences like putting a for, while, and then the for loop has 3 parts, whereas the while loop has only 1 part. But in terms of what you actually can do, is there a difference between a for and a while loop? Yeah, go ahead.
I'm also allowed to carry a paper, right?
Yeah, of course. The same as always. But is there a difference between a for and a while loop in terms of what they can do? Okay, so someone tell me the difference. Well, they use indices, but can I use an index for a while loop? Yeah, what I do is I make an index outside the loop and increment it every time I pass through the while loop. So is there something that a for loop can do and a while loop can't, or the other way? Yeah.
You can limit the distinct amount of loops for loop versus while loop.
You sure? Because what I can do is whatever the while loop's condition is, I can say, I can have this index thing where I say index is 0 and increment it every time in the loop. And then I can append to the condition and say, and this variable is less than the number of iterations that I want. So in fact, I can do exactly the same thing, yeah.
Well, for loop has to be limited. You have to know how many things you want to happen for for loop, while you could do.
You sure? What about that loop? Or what about this one? And I don't put anything in here. What does this loop do? It loops forever. So is there anything that a for loop can do that a while loop can't? No. In terms, I can convert any for loop into a while loop and the other way around. What about a for loop and a do while loop? Is there a difference there? Yeah, what's the difference? At a high level understanding.
Test the condition first for a while loop. Test condition.
Right. So what can I guarantee about the number of times I go through the loop for just a normal while loop? You sure? For a while loop? It could be 0 times. What about a do while loop? At least once. So there must be some loop that I can't convert a while loop to into a do while loop. Yeah.
Did you just paste the code inside the do while loop to outside of the while loop, and then it would essentially do the same thing?
Yeah, but I can't necessarily guarantee that the while loop's going to execute 0 times. Sorry, at least once.
That's why. So the entire contents of the do while loop are pasted in front of the while loop, and then you have a while loop. Doesn't that do the same thing as the do while?
Okay, so what you're saying is that I have a do while something like this, and then I have some int x right here, And then let's just say I see out some string. So what you're saying is copy this and then do what?
If instead you wanted to just use a while loop, you paste that in front of the while loop, and then you have the while loop with the context of it as well. While x is greater than or equal to 0, see out the
Okay, so let's see. So x is greater than or equal to 0.
see out the
And then this code, same before. But here's the difference. So if this, so the do while loop, let's just say executes n times. Okay, how many times is this going to execute? I know it does loop infinitely, but let's just say it would, yeah, it would do this loop n times, but I copied it out here and it does it n plus 1. So in fact, it doesn't do exactly the same thing. Yeah.
I thought the way you implemented the while loop was while loops is not you have a variable specifically set, and then you have it initialize to each root, and then you have it updated with the loop. So you're guaranteed on the first pass.
Yeah, but I need some way of going back through the loop. If I immediately set to false at the beginning and I never change it anywhere else, then I'm basically just removing the while loop entirely. So if I, for example, have a bool. Okay, so I have a flag here, and then I loop while the flag is true, and then what do I do?
Or honestly, just go to the while true, and then have a loop get something inside.
Yeah, so then if, then what? What's the if? Yeah, so let's just say int x is 10. This is not what I wanted to discuss. I wanted to go on to other things, but let's just do this anyway. So I break here. Put what at the end? So what am I doing? I'm copying this? So like int x is 10 right there?
No, whatever you're trying to do.
Okay. And so now what do I do? Okay, so what am I trying to show here? Okay, so what you're saying is that I could do this. Yeah. It's technically true that I can convert a specific while loop into a do while loop because I guarantee that this loop will execute at least once. So that will work. But if, like for example, this while statement depended on the user's input, then this could loop 0 times. But here I guarantee it does loop it at least once because the statement is true. So because I can guarantee that, then I can convert it to a do while loop. But if I can't guarantee anything, I can't guarantee to convert it to a do while loop necessarily. But going back to your question, it's basically trying to understand, should I use this concept or this one? And so what would another example be? So suppose that I have a bunch of numbers that are almost sorted. So like, let's just say that there's one pair of numbers in the wrong order. What sorting algorithm should you use? Should you use bubble or selection sort? Bubble sort, why? Well, what's bubble sort going to do? It's going to go through, and it's not going to swap anything until it gets to this one pair, does the swap, and then it keeps going. Maybe doing other swaps if necessary. But then what does it do next? It goes back through again, but what does it see the second pass? It's sorted. And so therefore, it'll exit only in 2 passes. What about selection sort? It doesn't matter. It's going to go through the list no matter what, no matter what the contents are. Even if it's sorted, it's going to do one pass through the array every single time. So it's understanding why these algorithms work or why one concept is better than the other, and in what situations should you use one versus another. What would another example be? So let's say this. So suppose that I have a gigantic list of people, say billions of people, and I want to perform searches on it. And let's just say that I do some number of searches, and I give you the number of searches. And so what should I do? Should I just do a linear search that many times? Or should I do this? Sort the list first, and then do binary search that many times. And so you have to think, which one should be better in which case? Okay? Any other questions about the final or anything else about the class? This is much more than I wanted to spend on it. Okay, so let's get back into material. So last time we were still talking about this inheritance thing, which is not related to wealth or whatever, but I have a object of a certain class, and I inherit from it to gain additional functionality if needed. So what's the entire point of inheritance? Can anyone tell me what the only reason for inheritance is? Yeah, to simplify code. That's the only purpose. So it doesn't achieve anything useful that we couldn't do otherwise. It's just that it makes code a lot easier to write and to maintain. But we can go on without it, but I wouldn't. So polymorphism is related to inheritance in the way that if we have a whole list of some objects, maybe with subclasses, so maybe we have a bunch of, let's see, where's an example of this? Yeah, so here's an example of this, and I'll go back. So suppose we have a bunch of objects of a type animal, but some of them are subclasses. So like I have a dog instance here, a cat instance here, and it's conceivable to think that dog inherits from animal and cat also inherits from animal. But let's just say I loop through this array and I call some function on each one. So the first time I'm going to call this ID function, whatever it does, on this first instance, then I'm going to call it on the second instance, then the third one. But what happens is that it's going to do the exact same thing every time. Even if the dog class implements this ID function differently, or the cat does either, because I declared this array of objects to be of type animal. So the compiler can't necessarily see, okay, you put a dog right here and a cat right here. Now I'm going to call a different function, the one that is specific to dog and the one that's specific to cat. I'm just going to call the animal version, and then everything's going to be straightforward from there. So that's where polymorphism comes into play. It allows you to do dynamic code at runtime. So when I call this ID function, if it's only an animal and not a subclass, I'm just going to call the animal version. But if I give you a dog object, it's going to see, okay, did you implement the ID function in the dog object, in the dog class? If you did, I'm going to call that one. But if you didn't, that means that you're just inheriting it from the animal class. So I'm going to go up to the animal class and call that one. And so on and so on. So yeah. So inheritance is basically just this. I have an animal right here, and I'm declaring it to be a new cat. I could just put cat over on the left side, but animal is perfectly good also. Okay, so there's one way that you can convert between different types here. So if I have an animal right here, so I declare it to be a new cat. So the type of PA really is cat, but the compiler sees this as an animal because of the type on the left side, which says that it is an animal. So if I want to convert it to say, yeah, you really are a cat, then I have to do this, what is called a static cast. So what happens here is that it's reinterpreting the bits of PA right here to say, yeah, this object now is a cat object. And it's okay here because I declared it to be a cat object. And so then I can convert it easily. If I instead said, okay, PA is a new animal, can I do this third line? If I just said it's a new animal, not a new cat, can I do the third line, the static cast? No, because if I declare it to just be an animal, it could be any other animal. It's not initialized to be a particular animal. It could be a dog, a cat, or any other subclass that we define. But if I declare it to be a new cat right here, I can safely static cast it to be a cat. So I don't really recommend using static cast that often, but it has some uses here and there. Yeah, so typecast just converts from one to the other. Just interpret the bits of one type to be a different type. So polymorphic code is a way of, instead of doing this static cast whatever, what we're going to do is that it behaves differently depending on the object type. So if it's the parent class, then I'm just going to interpret it as the parent class. But if it's a subclass, I'm going to call it to be the subclass. Okay, so the way that C++ actually does this is through polymorphism. So that's what polymorphism is. But the way that C++ actually